dear students. Today we'll talk about mathematical library methods. It's a very important chapter in your Java syllabus just because it will teach you some built-in functions. Okay, functions or methods, actually it's a part of program and it is used at different instances. Now some functions are created by the user and some of them already created by the system developers. Now we are going to use those function which is already created by the system developers, and also it is known as built-in functions, okay, or the library methods. And you must know that these functions are used worldwide or globally by the various users. Okay, so now today we will see about 10 important functions of library methods, and basically today we will learn the mathematical library methods or functions. Now in this mathematical library methods we have, it's a part of java.lang, which is a default package in Java. And then and when we want to use these functions we have to use a math class. Okay, so we have to write like this. Suppose, just see the screen. Suppose I want to use the mathematical power function, so I have to write math.pow, and in the parameter there is two value x and y. Maybe I want 2 to the power 3, then I have to write like this. Okay, that's all. Now we will see it in the actions, but before starting I want to just give you a little bit a glimpse, like power functions. We have square root functions, we have cube root functions, ceiling function, floor, round, abstract value and or absolute value, and max and mean and random. Okay, so we are just going to use them in the programming in the live, some with some live examples. So let's start with the BlueJ environment. And already you can see I have created a new project, class 9 math, and here I'm going to write an intro. Okay, so using this program I'm just trying to give an intro, and here we go. Public static void main string argument. So first simply I have given this one, and now here I'll write. You have to remember that this power, it is always gives you return in double. Let's see it, let's prove it. So I have written system.out.println, and inside this one I'm going to write math.pow. Pow is a power function, and using these functions you can get a power of any number without writing your own mathematical expressions. Okay, so I want power 2 to the power 10, and guess what you will get. So let's run this program and see. So 2 to the power 10 is the 1024.0. You can see it is giving result in decimal values. That means this power function always give return in double value. Okay, so anything you want to put, you will get it. Suppose let's put 2 integer a and integer b, to separate, or integer x and integer y, and here I will put x comma y. So we can put the value of a parameter, and when I will try to run, maybe 2 to the power 3, so the answer is coming 8.0, and 2 to the power 5, the answer is coming 32. Yes, so you can see how this power function is useful, and it is very powerful too, because without writing your own mathematical expressions you can easily get the power of any number. Now let's see our next example, which is the Sqrt, that means the square root. Similarly, you can get the square root of any number, but to get the square root of a number, Okay, to get a square root of a number, you just have to write like this, Sqrt, and you have to put a number. So let's do one thing. Let's take a scanner class and let's make this program little bit more interactive. Let's java.util.scanner. Okay, and here let's create an object of scanner class. Scanner input equal to new scanner, and in the parameter system dot in, here we go. Now before just starting it, I'll try to write this one, enter two number for power x comma y. Now what I'll do, instead of taking it from here, I can write down integer x equal to input dot next int. We have learned about how to use the scanner class and how to get the input from the user. So here I have written an example, written a code so that I can collect the number from the user, and similarly here I'll try to put the same question for my user. Okay, so here instead of println I'll give print, it will be better. So the same line I can keep the values. Okay, so let me put the video here. Okay, so now let's close and run the program. So it is asking me for the number to number, maybe 10 to the power 10. If I hit, the number is coming like this, and then I have to write like enter a number for square root. Sorry, I made a little mistake here, just wait. Okay, so power here, and when I am writing enter a number for the square root, what I have to do, I have to collect the number from the user. Maybe if it is x, again I have to write input dot next int, so that I'll able to collect the next number from the user and then I can display it. So again I'm running, so I'm giving 5 to the power 3, so it is coming 125, and now enter a number for the square root, maybe I'm giving 36, so yeah, I'm getting 6. Okay, that's great. And similarly I can do the same with the next function. So we have a next function, it is also known as Cbrt, or the cube root of a number. So like you are getting the square root, similarly you can get the cube root. I can repeat the same here. Let's just copy and display the same here. So I have given the line here, enter a number for cube root. So when I have written the enter a number of cube root, I am getting the number at x, and here I'll change the function from Cbrt to from Sqrt to Cbrt for the cube root, and I am passing the number x here so that I'll get the value. Okay, so now let's close it, and if I run it, so let's repeat the same, and maybe okay, and cube root. Okay, maybe I'm giving maybe 600, so the cube root value of 600 is 8 point something, which is completely double. So I want to say that we have used a power function, we have used the square root function, we have used the cube root function. All these functions, in the return they are giving a double value. Okay, so keep it, remember that power function, square. So you have learned this of almost three functions: power, square root and cube root. Now I'm going to introduce the ceiling and floor functions, okay, where you will get the ceiling value of a given input and of a floor value of a given input. Okay, let's see it in the action. Okay, so I'm just going to create another one function because it is getting a little bit lengthy, and we have to give lots of input, right? So now let's create one more, maybe main2. Okay, where similarly I have to create an object of a scanner class. So I have created an object of a scanner class, sorry. Okay, now so I'll write my user to enter a number for floor and ceiling value. Okay, so what number user will enter, I'll collect it inside maybe integer x, then I'll write sc dot next int. So now I have the user input. Now I'll just try to display like this: floor of x is, now here I'll write math dot floor, and inside parameter I'll write x. So I'm just trying to display my user what is the floor value of x, and similarly I'll write ceiling of x is math dot ceiling and x. So here I'll collect a value and I'll try to display what is the ceiling and what is the floor value. Okay, so I have done with the program. You can see once more. Let me explain. So here I have created the scanner object, and the next line I am just asking my user to enter a value, and I am storing at a float x, and I am writing sc.next float so that I can able to collect the float input. And then I'm just displaying the floor of x is math.floor x, and the ceiling of x is math.ceiling x. So now let's see it in the action. So if I hit main2, it is asking me, maybe let's put 2.6 here. So you can see the floor value of 2.6 is 2.0, because yes, floor means the bottom value. So what is the bottom value of 2.6? It is a 2.0, and 2.6, so after this 2.6, what is the value? It is 3.0. If I open the word here also, I can write like this. So it's coming like this 2.0. okay, and after that maybe 2.1, or similarly all the things are going on, and maybe here you will find somewhere 2.6, and after that you will find out 3.0. So it's like this 3.0, then say 2.6, then 2. So if I'm standing here, the floor value is 2.0, and if I'm standing here, the ceiling value is the next ceiling value, that means the round up ceiling value is 3.0. okay, so I hope you got the idea, but it is working little bit different way with the minus value. Some of them might get confused, but please don't. Here I want to show you same thing. Suppose I want to give minus 2.6 here. So for the minus 2.6, minus 3.0 will be the floor value, where minus 2.0 will be the ceiling value. Okay, so after this floor, I'm just going to show you one more function. It is the round function. Okay, so the round function I want to introduce. So let me copy the function, and here instead of main, let me write round. Okay, and here please number for round off, for round. So similarly I have the number. I'll just try to comment this line, and I'll write here round of x is math dot round x. Okay, So I'm done with this program, and let's close and run the round function. So see what is the difference here. If I put 2.4, the round off value will be 2. Okay, if I put 2.8, so it will be round up and it will go to 3. And if you put 2.5, it will be also 3. If it is 2.49, it will be 2. So in this matter, what I can say, a round function, if the value is up to 0.49, it will give you the next possible integer, and if it is up to 2.49, it will give the ceiling value. Okay, sorry, it will give the floor value. If it is up to 0.49, it will give you the floor value, but if it is from 2.50, it will give you the ceiling value, that means the next available value. Okay, but you have one more function, additional function, it is known as rint, that means round integer. I want to show you the same thing also here. So rint functions, it works a little bit different here. Okay, so let's see it. So if you put 2.49, if you put 2.49, you can see here rint functions always gives output with the with this double one changes here, but round it is giving you the integer. Okay, and the second change it is here. If you put 2.5, you can see the 2.5 round out value is 3, but 2.5 round integer value is 2.0. This is the difference here with the round and round int. And if you put 2.51, then it will be something different. Okay, if it is 2.51, both cases you will get 3.1, you will get 3, and another one you will get 3.0. But the confusing part is if you put 2.5. Okay, so then with the round function you will get the next possible integer, that means you will get the ceiling value, okay, of 2.5, but with the round integer you will get the floor value of 2.5. so this is the difference here with the round and rint functions. Okay, now let's see the ABS, that means the absolute value. Absolute value is nothing but it's a function where you will get public static void ABS, and here I'll write, maybe in the parameter I'll take, since it's a very small, let me do it like this, system.out.println, and here I'll write math.abs. And one more thing I want to mention, you can see I have not imported any kind of other libraries, just because this math, it comes under the package of java.lang, which is the default package. You don't have to import anything, and for using the for taking the user input and for using this scanner, I have used the scanner class. Okay, now I'll write here a. So now let's see how the ABS function it is working. Now if I hit here, maybe if I put 2.5, it will sorry, maybe I have taken integer, just 1 minute, float. So float, so maybe if you give 2.5 f, so you are getting the 2.5 f same, okay, the same value. But if you give minus 2.5 float, then you will get its positive value. Yes, the absolute functions always returns the positive value of a given number. So if you are passing a negative number, it will give you the positive value. Okay, so this is the thing. Now we'll see another two functions, which is a math.mean and math.max. Minimum and maximum. It is also a very important and popular functions too. Let me put a name max mean, and here I'll write integer a and integer b. Two integer I have collected, and now what I'm going to do, I'm going to write system.println. With here I will write the maximum value, and I'll just write math dot maximum. So no need to put a complex if else system. So I'll just write a and b, so it will try to get the maximum value from this a and b. So we have one minimum also. Oh, sorry, I made a mistake. It must be the same, and here I'll write math dot mean and this two value. So if you close it and if you run the function this max mean, and if you put two things, maybe I'm giving 52 and another 25, so it will say the maximum number is 52 and minimum number is 25. So you see how easy it is to use these mathematical functions, and how easily you are getting your desired or your expected results. So you are getting your desired results, you can do whatever you want with the mathematical functions, and without using if else also I'm getting the maximum and minimum. So it's a big program generally, so a big program also you can minimize the thing by using the user defined, sorry, the by using the system defined or predefined mathematical library functions. Okay, so now we came to the end of the class, where I'll show you the random functions. It's also a very important functions. Okay, but the working method, it is little bit different here. You have to understand how it is working. Now I'll show you with some simple example, and later I'll show you some more complex example. Maybe it's a random function. Maybe I have given a name rand, and here I'll write, I'll not take anything first, and here I'll write system.out.println, and here I'll write math.rand. Always try to write a math m in capital, otherwise it will not work. Okay, so if you write math.random, let's see, it will not give you a value between 0 and 1, it will give you a value between, okay, let's say 0, from 0 to just before 1, all the possible decimal values you will get. So just like this, so it will not reach 1. Okay, it will not reach to 0 also. So from 0 to be just before 1, what are the possible decimal values you will get. So it's a really very big number. Okay, but to make it useful in our daily examples or a real life scenario, what we have to do, we have to put little bit more expressions so that you will get the thing. So now what I want to do, I want to put it like, I'll put a number integer n, and I need or maybe a random number between 1 and this random number. So you have seen random also giving value in decimals. So what I'll do, maybe integer result equal to, I'll try to put explicit conversion here, and this side I'll write math.random multiply by n plus 1. Okay, and here I'll try to show the result. So if you close, if you hit the random, and if I put 100, so it will give you a number between 1 to 100. Okay, so let's see within giving 5, so it will give any number between 1 and 5. So if you hit the same function with the 5 only, separate time, all the time you will get separate values. You will not get a single value. Maybe once again I'm getting 1, I'm getting 3, I'm getting 2. Again you write 5. So maybe you are getting 5. Again you write 5. So you will get always a different number. You will not get a same value. Okay. And similarly, if I want to show you the thing, like instead of writing like this, if I put the same thing, if I put the same line of code, you can see also it will give two different results, because random function will always create a value. Maybe see, I have written the same code for a random number between 1 to 10. So once it is giving 8, another second time it is giving 1. Okay. So this is the way of how it is working, the random functions. Okay, so math random function, it will give you a decimal number between 0 and just before the 1. Okay, so if you want to any number between 1 to n, you have to write math random multiplied by n, then you have to add with 1, you have to plus 1. That's all, then you will get the thing. Okay.